Now it's time to start talking about another type of class. And this class is called the data class. If you have any experience with Java object-oriented programming, you probably know about POJOs, which is an acronym for plain old Java objects. It's a class to use to hold data. So now Kotlin implemented a thing called data class, which will help us create a class to hold data. The awesome thing about data classes is that the compiler automatically generates utility functions for the class. This includes equals, hash code, toString, component n, and copy. And we'll go through each one of these utility functions one by one so we can see them in action. To create a data class, all we got to do is go to source, new, and then Kotlin class, and then we'll just make one for employee. And then I'm gonna create a data class. So I go down and select data class, and boom, now we have a data class. The only difference between the declaration of a data class and a class so far is the keyword data in front of class. But there are some rules to create a data class. First, you have to use at least one parameter in the primary constructor. So right now it's showing a red squiggly line because it wants at least one primary constructor parameter. Parameters passed in the primary constructor has to be marked by val or var. So we'll just make a val called name, and that's going to be a string, and that will meet that criteria. Last thing, data classes cannot be abstract, open, sealed, or inner. So if you want any of those type of declarations, that can't be done with data class. Like I said, data class is used to hold data. So if you want it to be abstract where people can inherit from it, that's not what a data class is used for. So it can't be open as well. Things can't inherit from it. And we're going to talk about sealed classes later, but it can't be a sealed class, and it cannot contain, or it cannot be an inner class. So now we have a data class that takes in the name, which is going to be a string. Now we'll see some of the utility functions that a data class comes with on compilation. So let's go back to our main and let's comment all of this out and start from right at the bottom. And we just created an employee data class, so we'll create an instance of employee equals employee. Oops. Alright, cool. And now it's expecting the name in the constructor, in the primary constructor. So we'll just use Giovanni. So now we'll start using the utility functions that a data class comes with on compilation. The first utility function we're going to use is the toString. The toString returns the string form of the data class. So currently we just have one parameter that we're passing into the data class, and it's storing that as name, and that value is Giovanni. So let's see this in string form. If we do a println and we do employee, which is holding the instance of employee with my name, and do toString and run that, we should see the string version of my employee using my name. So it's gonna be employee and the name is equal to Giovanni. So that's pretty cool. If you have a instance of an object and you want to see what's under the hood in a very nice to see format, the toString would work. So that's one utility function that comes with a data class by default. And let me just go into, I believe it's in building, and take this println out. Alright, so the next utility function that a data class comes with is the .copy, which, just as the name implies, the copy function just creates a copy of the object that you're trying to create a copy of. So let's see this as an airplane passes by my house. Val employee2, which is going to be the second instance of an employee, and is going to be equal to employee dot copy. Now we're creating a copy of employee, but we got to pass in the parameters for the employee. So since there's only one parameter for employee at this moment, which is just the name, we'll just pass in a new name, which is going to be Jim, which is pretty cool. Now we can create copies of objects without having to create a whole new instance of it. Like now we can just take that instance of employee and just use a dot copy. Pretty convenient. And it's pretty much saying right now with swigglies that we're not using the name arguments, so we can just use name and equal, and that should go away. And now we can just do println and do employee 2.toString just to see how it looks under the hood in a very nice format. And then boom, employee, the first one's gonna be Giovanni because it's this one, and the second one's gonna be employee name equal to Jim, which is this one. So now we have a copy but with a different value. Awesome. Another utility function that we can use is the hash code function, which returns the hash value of the object. So if two objects have the same hash value, they are equal. So let's see what the hash value for employee 1 is, and we'll just put that right after. So we're gonna make a nice little prompt, hash value or hash code of employee 1, and we'll just do string templating, and we'll take the instance of employee and do hash code, and boom. And then we're just gonna copy this, put that right under employee 2, change the prompt just a little bit, and then we're gonna do employee 2.hash code so we can get the instance of this hash code. Now if you run this, we will see, boom, employee 1 has this long hash code and employee 2 has this hash code. So they're two different hash codes, so that means they're not the same object. And there's an easy way to check if an object is equal. So that takes us to our next utility function, which is the equals function, and this takes in an object to compare with another object to see if they have the same hash value. If they do have the same hash value, then it returns true. If not, then it returns false. So we can just make another println. There's a lot of prints going on, but it's just to see, to output something so you guys can see. So we'll take the instance of employee, then use dot notation to see the functions or the methods that the data class provides, and that is the equals. And then we'll pass in the object that we're trying to compare it to, which is going to be employee 2. And what is this rest wiggly? And we could use the equal to compare as well, but we're going to do the dot equals, and we're going to run this, and then boom, it's false, because we can see here that this hash code and this hash code is different, so they're not equal to each other, so it returns false. When is it going to be true? When is dot equals ever going to return true? And like I said, it has to be equal, or it has to be the same hash code. So when is an instance where an object can be the same? Let's see this in action. So let's create another instance of employee, and let's do employee 3 because this is going to be the third employee. Probably should make a more specific name, but employee 3, and we're going to make this equal to the copy of employee 1. But we're not going to pass in any values. We're not going to pass in a new name because that would change the object. We're going to make it an exact copy. Now we will pass employee 3, which is a copy of employee, and we're going to run this. And as you will see, it is now true. So this is an instance, right? Maybe by accident you created a copy and it's the same object. This is an example of the same object being checked to see if it is the same object, and in this case it is true. There's an age limit to whether a person can be an employee or not, so that would have to be put onto the application regardless. Alright, and that's going to be an int. Let's go back to the main and let's use component n. So by default, component n is generated for each parameter, like I said, for destructuring. So let's do that. Let's extract the parameters that we have for an instance of an object. We're going to do name, age, and that's going to equal to employee. and this is probably looking ridiculous, but let's do this so you can print it out and see what's exactly happening. If I can spell println right. Let's do employee name is name and age is age. And we'll run this and be amazed. So look, an employee name is Giovanni and age is 20. Like how, right? So with the component n that is generated for each parameter, we have the ability to destructure, which means we can extract them. And with this notation right here, we can extract each parameter. If we put in parentheses and pass in the name of the parameters, we are now extracting those values from this instance of employee and assigning it to these variables. So now name and age is the name and age in this employee. So now we can just use that n-word that we like because we just extracted because of the component n generated for each parameter. So data classes come with so many utility functions that will be necessary for the stored state that we have for each instance of a data class. So that's one thing you got to think about. If you want a class to store the states or that's going to hold data, a data class is perfect. Now if you want something that needs to be inherited from, or you want a sub class or an inner class, then a data class is not for you. But if you know you're gonna store some data and you're gonna need some of these utility functions, then a data class is perfect for you.